Hello, in this video we're going to look at the online simulator that we'll use to build our electronic circuits. So go right ahead and type the word Falstad, F-A-L-S-T-A-D, into Google. The first result will be Circuit Simulator Applet, so click on that and you'll see full screen version here. Go ahead and click the full screen version and you'll be met with this circuit. So it starts up with a circuit already built, but we'll drag a box around that and press delete on your keyboard and that'll get us a blank canvas. So to use this software you'll be using your mouse and your keyboard for shortcuts. So if you press the letter R on your keyboard, no need to hold it in, just press an R and then drag your mouse about the screen in various positions. You'll see that the R is a shortcut for resistor. So we're drawing a whole bunch of 1000 ohm 1K resistors. If you press C on your keyboard, that's short for capacitor. If you press L on the keyboard, it'll draw an LED. And W on the keyboard is for a wire, which is what we're going to use to join these. So just go ahead and randomly join some stuff together, just to get the hang of it. If we want to insert a voltage source, a battery or an AC supply, we press V. And usually I draw, if it's a DC supply, like this, a battery, it's best drawn up the way rather than down because you want the positive at the top. So drag up the way to draw your battery. Now you'll notice here that your mouse pointer is a crosshair. Now that shows that you're in drawing mode. So while you're in that mode, it will continue to draw whatever the last object was. In my case here, it's another voltage supply, another battery. In order to get out of drawing mode, you need to press Escape top left on your keyboard. And you'll see then when you do that, that the cross becomes a standard pointer. So now it's not going to draw items. It's going to allow you to highlight them by drawing a box around. So draw a box around everything and just hit delete to get rid of those components. Let's get our first little circuit built just to get a hang of how to use this software. So I'm going to press V for a voltage source, drag it up the way. Then I'll press R for a resistor and L for an LED. W for a wire. And you'll see as soon as we join the circuit, you'll see the yellow dots indicating that you've got a flow of current. So there's a flow of electricity here from the positive of the battery, right round through the resistor, through the LED, back to the negative of the battery. Because I've finished drawing this circuit, and I don't want to draw any more items like this, I'm going to press Escape to get back to the pointer, and I'll just draw a box around those to get rid of them. So now that I'm out of drawing mode, I can move the components around. But the first thing you'll notice here is that the components move, but the connections between them do not. So if you move a component away, you're going to break the circuit, but that's okay. We can remake it again. I can do without this little wire, so delete that. And here, rather than move the wire across, I'm going to drag it by going to the end. Same here, and you'll see as soon as it makes contact, our circuit's made again, and there's current flow. Let's replace this top wire with a switch. So My mouse pointer is an arrow here. So I'm in the, I'm not in drawing mode. So I can draw a box around this top wire. It highlights blue. Press delete. Then I'll press S, which is a shortcut for switch. And I'll drag in a switch. And again, I want to come out of drawing mode. See this crosshair? So I'm going to press escape. And now, just simply clicking on the switch itself will open and close it, and you'll see the current flow start and stop. So next thing I'm going to do is to stop the circuit. So up at the top right here, you'll see run and stop. I'm going to press escape to get out of drawing mode, and I'm going to delete this LED. And I'm going to add a capacitor in here, so C for capacitor. And I want to change the value this time. So having drawn it in, I'm going to press escape again to get out of drawing mode, and then double click on the capacitor and change that to 100. And there's a little U at the end here, short for micro, 100 microfarads. I'm going to open the switch, and then I'm going to hit run again to run the circuit. And I should see now that when I close the switch, we get a flow of current. Oh, sorry, one other thing I'll do is change the battery voltage. So I've changed that, as you can see there, up to 50 volts rather than 5. So just double click on that to change. And we should see then that when I close the circuit, there's a much higher current flow because we've changed the battery voltage up to 50. And but we should see it tapering away as the capacitor charges up. So click on your switch, you'll see the current flowing around, and it should decay to the point where the current stops flowing once the capacitor is completely charged. You don't have to start and stop the circuit in order to move parts, but it's a good idea too, because sometimes it can kind of lock up. So I'm going to stop my circuit there, and I want to put in 2 resistors at the top here, side by side. So I'm going to copy that resistor, Control C, Control V, and that makes us a duplicate. I'm going to move this across because I want them connected up in this fashion, where the current flows down through both resistors and then the capacitor. So you may think that you can simply drag this across to here, insert a wire here, and drag this across to here. But what you'll notice there is that we have a red dot there and a red dot there. The reason being that this is a warning sign that this is not a connection. Here, the top wire has simply moved across the top of this resistor without actually making a connection to it. So you can't drag across a node like this and expect it to be a connection. I'll show you how you need to do that. It's best to add in 2 separate wires. So I'll just go back to where I was using Control Z. So here I would drag this to here and then press W for another wire. And now you can see there's no red dot. Similarly here, use 2 wires, wire from there, wire from there. And at the bottom, because we've only one connection, we can just drag it across. And you can see when you switch it on that the current flow is through both, and then the flow joins at the bottom to run through the capacitor. So do be careful about this when you're building your circuits. The most common problem if a circuit looks correct but isn't working is that there's a red dot somewhere highlighting the fact that you think it's a connection but it isn't. Okay, let's delete that. just draw a box around the whole thing, and we'll look at a simple AC circuit. So I'm going to press V again for a voltage source and drag up the way. W for a wire, top and bottom, and then R for our resistor. Simplest possible, simplest possible circuit. And I want this to be an AC circuit, alternating current rather than DC. So I'll double click on the supply, and you can see we can set it there to AC. And having selected AC, it gives us an option for the frequency. So let's set that to 50 Hertz, which is the standard throughout the UK and Europe. And we'll set our voltage here to something a little bit different, let's say 25 volts. And running that, you can see the animation, the yellow dots representing the current flow back and forward. Now you'll notice, although this is 50 Hertz, meaning 50 times per second, the current flow that you can see here is certainly not 50 times per second. It's only reversing about once per second or once every 2 seconds. That's because these circuits actually run in slow motion. And you can see here at the bottom the actual time. So we're still at the 2 second mark, not quite at 3 seconds yet. So bear in mind that these circuits run in slow motion just while the software does the mathematics. It is possible at the top here to speed up the simulation, but we never quite get to real time, as you can see here at the bottom. It's still pretty slow, but it's usually best to keep it at a sensible speed so that you can see what's happening.